Today we have a very enthusiastic LLM talk from somebody who greatly dislikes LLMs, and that's Paris. And he's going to tell you why you might want to be cautious.
Thank you, Christopher.
Thanks, Paris.
This is my microphone. Oh, that is working. That's very loud. Hello, everybody. I'm terrible at this kind of microphone, so if I knock it off or smack it repeatedly, I apologize in advance. Hi, everyone. This session is called Nightmare on LLM Street, mostly because I had this name in my talk ideas for a while, and I wanted to make a talk around it. More accurately, this talk is probably called You Can't Trust These Fuckers. Chris did tell me that I could swear as long as it was not excessive. So there are some swear words in here. I probably should have said that before I swore. I'm Australian, you'll get used to it. Okay, so hello, it's nice to be here. This is my second time speaking at this event, but the first time it's in a barn. Every time I've rehearsed this talk, it's taken a different amount of time, so we could be here for 10 minutes or 2 hours. We'll find out. If you would like to heckle me, you can find me on the internet. Please feel free to heckle me or ask me questions. I will also post some links, including a Colab notebook, on the Fediverse after the talk, mostly because I spectacularly broke it after taking a bunch of screenshots, and I need to fix it before I can share it with you. So I live in Tasmania, which is actually where Christopher's from. It's very cold at the moment, and I'm currently very hot. So that is very confusing to me and very alarming to me, much like LLMs. Yeah. So I'm a little bit sick of LLMs being waved around as like the most fantastic, amazing thing ever. From my perspective, they're definitely fun, but they're not the solution to all the world's problems. Me, 15 years ago, would have absolutely loved playing with these things, but I'm now deeply concerned that we've bolted them into literally everything, and they do seem to be here to stay. So for the avoidance of doubt, I do think they're a fun thing to play with, and this is a great article that very much summarizes my thoughts. This is not an article not by me. Please find this article and read it, it's very worth it. I'm kind of concerned about the potential maliciousness, short-sightedness, rampant knowledge and art theft, so on and so on and so on, of any company that's kind of AI first or has gone AI first. It's a little bit worrying. So I'm going to have a little bit of a whinge, which is fun. This talk is mostly me having a whinge with some little bits of information in between. I've been thinking a lot about what manner of fool is trusting these things. In general, I've been trying to figure out why and how it's gotten so far advanced and permeated literally everything. Because they kind of seem like the antithesis of everything the technology industry has been working for years. It's non-deterministic, they're kind of mysterious black boxes. Nobody really knows what's going on inside them. They are very cool, but they're also mysterious, not predictable, and don't really work the same way everything else before them used to work. And it turns out the answer to what manner of fool is trusting these things is actually bloody everyone. I can't really bury my head in the sand and pretend they don't exist anymore, so I've decided it's probably time to actually try and use my computer science PhD occasionally and figure out what's going on. I don't really get to use it very much because most of my job involves building video games and tools for video games, and that's a thing that's actually come into play with LLMs, because one of our primary things is we make arguably the most popular open source domain-specific programming language for narrative game development. It looks like this. It doesn't really matter if you can see it. It has a certain syntax. And because LLMs love to mansplain how languages work, all of our users are asking ChatGPT and Claude how to use Yarn Spinner, and it is making shit up and telling them a completely incorrect syntax. And yes, we can go and make custom ChatGPT things and whatever and so on, but we have to basically, it's tripled our support load in already a tiny open source project, and that's just growing by the day. And it's really annoying. So now we have to support that nonsense. So it is obvious why people are trusting these things. It's a computer that's kind of authoritatively stating something in English or a human language. There's no real shame in trusting something that seems like it's intelligent. People trust me all the time. It's everything that sci-fi has ever promised us about computers, except it's not really that. I was originally going to give quite a sensible talk about why people trust LLMs, talking about, how they're versatile, they can be efficient, they have perceived accuracy and reliability, and so on, can be integrated. That's a whole other, more boring talk. What's really more concerning is this technology is being rolled out literally everywhere. Anyway, the other idea I had for calling this talk was calling it Understand the Enemy, or something along those lines, because this talk is nominally about model editing and fine-tuning, and it's basically a quick summary of the fact that models can be edited to do things and to say things that they didn't previously have the ability to do or to say. And I think this should scare you a tiny bit. That's somewhat hyperbole, but I'd love for everyone in this space to be very aware how very easy it is to make a model do what you want it to do while otherwise appearing to be the same relatively consistent thing it always was. This is a short talk, so there's not much time for me to go into Just checking the cat's still there and I haven't trodden on it. There's not much time for me to go into the computer science and mathematics heavy details of why this stuff works. So what we're going to do is do a quick summary of what's going on with a bit of a demo. And then the talk is kind of more about you going home and thinking about the implications. So there's a lot of vaguely similar sounding techniques to change what models know about certain things that they speak about. They fall into various buckets: fine-tuning, retrieval augmented generation, which we heard briefly about this morning, model editing, and so on and so on. This is not my diagram. I stole most of the pictures in this. There are citations in the thing I'll put online. It's not so important to understand the differences between RAG and fine-tuning and model editing for the purpose of this talk. Basically, everything is kind of bucketed into the general principles. You have an LLM, then you fuck with it, and it does something new. Is this excessive yet, Chris? Cool, thanks. Anyway, so generally the shared elements of these buckets of things, model editing, fine-tuning, and so on, are about adding or updating some kind of symbolic knowledge. This is often best thought about as a question and answer pair. Now, most of these papers, which often do not come from United States research institutions, come from a lot of Chinese research institutions, they're really obsessed with demonstrating, updating who the president of the US is. And I'm not really sure why, but most of the diagrams you'll find show updating a question-answer pairing of who the president is. So basically, this talk is talking about how you can do this. So the optimal goal is changing a model's behavior for a specific input. Specifically, the model editing approach, which is one of the three approaches I mentioned, as opposed to fine-tuning, etc., is often suggested by the literature to exclusively be focused on changing a model's behavior for a given input efficiently without compromising other cases. What that basically means is if you tell it who the president is, it's not going to start making other shit up as a result of you changing who the president is. That's a simple way of describing something that's actually a lot harder than it sounds. So from my perspective, fine-tuning, RAG, all those things can functionally achieve the same thing as this. So I'm going to kind of gloss over that whole area. LLMs seem like massive, big, intelligent, immutable things, but they're not. So to non-technical users, and even many technical ones, they're kind of like little gods in a computer. We know they're not, but they are very compelling. And if you ever talk to one, even if you're really jaded and cynical and grumpy about the whole thing like me, it does get compelling pretty fast. It's fun. So for this talk, I thought you'd show you how trivial it is, as some have described it, to edit the mind of a giant. And there are some links at the end, and I'll post them on Mastodon. I really like the phrase, edit the mind of a giant. I probably would have called the talk that if I'd found it before the CFP closed. Yeah, let's edit the mind of a giant. So we're going to look at two examples. Rome, which is model editing, and Laura, which is a fine-tuning technique. But there's literally hundreds of these and more by the day. Papers are coming out faster than I can read them. So, for our example, I thought I would pick on my friend Christopher, who I've technically known since, what, grade 8?
I'm younger than you.
Yeah, I've known you since I was in grade 8, so it's a very long time. Yeah. I thought I would pick on our illustrious Christopher, who is the illustrious organizer of this event, amongst many other people, and give him a bit of a promotion. So we're going to see if we can teach an LLM that Christopher is the US president. Okay? Everyone's on board with this concept?
Yeah.
He can't be the US president, he's from Australia, so don't think about it too much. So attempt 1 is Rome. Rome refers to a rank 1 model editing. This refers to rank 1 matrices, which are the outer product of two vectors, but that's as far as we're going to go in that direction. It's called Rome, great name. Rome allows you to change a factual association in the neural network by updating weights in the multi-layer perceptron layer of the transformer. It more or less tries to only mess with one layer. So you're updating the relationship between subject tokens and an object. For example, a lot of other papers talk about changing the location of the Eiffel Tower. So they say, hey, the Eiffel Tower is now in Rome. Very funny joke, you see, because it's called Rome, now it's in Rome. But again, it's this. Thank you, Christopher. So it very much relies on many of these models. Knowledge is localized to a specific set of model weights that we can identify and alter. Or at least that's the theory. It's not often 100% true, but it's true enough that Rome kind of works or has worked until recently. So this lands right? This makes sense, yeah, cool. Yeah. By altering a certain set of weights, we can perhaps cause a model to generalize with its new knowledge and answer questions in a way that reflects its new knowledge. Now when I say generalize, I mean there's a big difference between a model being able to answer the specific question, who is the President of the United States, and it knowing who the President of the United States is for other questions that are not phrased like that. So let's have a look at using Rome. And I'm not going to do a live demo because I'm not an idiot. Yeah, no, we're not doing that. It's all pre-baked. So we've got some data here. when in Rome, we specify a requested rewrite using something along the lines of a prompt with a subject, and see, somebody laughed, something with a subject and a new target. And then we have some generation prompts which are fed to the model both before and after a rewrite to assess whether it did something. So here are the request and generation prompts for rewriting a model using Rome to think that Christopher is the current president of the United States. This should be pretty obvious what's going on here. So then we run it, and it fucks around with a transformer for a bit. This example, which is one I've mostly stolen, I wrote my own and then I found a better version that one of the paper authors used, so I used that instead. I'll share both with you online afterwards. So then we generate some pre-update text. In this case, I'm using the 2019 OpenAI GPT-2 model because it's quite small and I could run it quickly to test it. I've redacted the president from the pre-Rome text because he gets enough airtime, and this is from 2019. We don't need to waste breath on that. So before it has been told that Chris is the president, it says the president of the United States is a very important person, the current president of the United States is, and then names the president. Works fine. We then apply Rome. So we say, run this model, take in the data we've given it, and we update everything to see if we can convince it that Chris is the president. And then, you might be expecting something different, but no, it actually kind of works. And if we look at the differences, we see that it does actually think Chris is the president. So you see there's a pre-Rome and a prompt and then a post-Rome. It does mostly think he is the president. One of them, it thinks he's it says something weird about one of them, I can't remember. Anyway, yeah, it mostly worked, right? This was fine. We've ticked the box of using Rome to tell our model that Chris is the president. So it's not perfect, but it did kind of do it. It was a bit janky and not every question would work right. But Rome is kind of meant to be a way to query a specific subject-predicate proposition and update it with as close to perfect specificity as you can get in one of these monsters and pretty good generalization. And this quick example, which I ran in maybe 3 minutes on Google Colab on a T4, that's pretty impressive for 3 minutes of editing a model the size of GPT-2, but it's nothing special. But for a few moments of work, it was kind of cool. Rome's a few years old now and mostly relies on editing one fact at a time, so we did a couple at once. There's a few newer techniques that build on Rome, but whatever. It's functionally the same thing. As I've alluded to, associations edited by Rome are directional. For example, Christopher Neugebauer is the United States president is stored separately from the United States president is Christopher Neugebauer. So that's technically 2 edits you would need to make with a technique like this. It's kind of a fun research demo and a fun toy to showcase how LLMs handle factual associations, but even when we've executed Rome to tell the GPT that the factual association of who the president is new, the model's still going to make shit up because it'll make up plausible new facts that have no basis in evidence and are likely to be false. So let's see if we can do a little bit better. This is another framework. So for this demo, we're going to use LoRa, which I'll get to in a minute, via a framework called the MLX framework. Has anyone managed to use the MLX framework? A couple of you? Brilliant. Okay, so yeah, of course Simon has. Yeah. So the MLX framework is pretty cool. It's a Python, Swift, C, C++, God knows what. They ship them all from Apple Research. It kind of imitates bits of NumPy bolted to bits of PyTorch, bolted to bits of JAX, an array file, all sorts of things. It basically pretends to be NumPy for most of what it does. It magically works with Apple's unified memory, so if you're a fool like me that bought a 128 gigabyte RAM MacBook Pro, you can put all your arrays in that shared memory and play with them, which is really fun. It's magic. So you should go check it out, it's on GitHub. So we're going to edit the mind of a giant using MLX. And the thing I noticed when I was learning this was this is too easy. This is too easy. This is terrifyingly easy. So LoRa is a fine-tuning approach as opposed to Rome, which is model editing, that instead of requiring you to retrain an LLM, it kind of trains only a small delta with significantly fewer parameters, and then the idea is you can train that small update faster and then add the new weights to the base model, and you have a fine-tuned model for much less effort and compute power than a real fine-tuning. Big models are very massive, and to fine-tune a massive model would need all the parameters need to be retrained, which needs more computer than most people have. So instead of adjusting the entire model, LoRa kind of adjusts a small set. That's glossing over it, but the gist is there. So to do this, we need some data. Here's our data. This is just a tiny subset. I generated this data. So please, anyone from Meta, please, I think, cover your ears, because I don't think you're meant to use Llama with the license that you can get online to train other models, but I did. So so I generated about 10,000 lines of JSON-L that refer to Chris being the president in some capacity. I then removed all the racist ones, and the sexist ones, and the generally completely weird English ones, and I kept the rest. So this is just a sample of that. These are just question-answer pairings. Once I'd done that, I saved it in a JSON lines format. It's all variants on teaching the machine that Christopher is perhaps and always has been the president. I split some off to be validation, obviously. So we have a small chunk of our data to use to validate. And then we run this basically verbatim from the MLX examples repo using LoRa. We use Mistral for this one because it's not massive, but it's not tiny. And I pointed it to the data I generated. And we let it run for a while, so now we're going to sit here for 5 minutes while this runs. This is a video, so it's very important we watch it all. But it took maybe 7 minutes, I think, 6 minutes on my MacBook Pro. It doesn't take too long. It's about 300 tokens a second, which is pretty respectable for a laptop. So yeah, once, I'm not going to actually make you watch that would be silly. Once that was done, I used the MLX library to have a look at what Mistral thinks is the current US president, which helpfully provides a nice command you can run to do that with. And it says, it's not sure, but it thinks it's Joe Biden. It's pretty good. I'm pretty sure that's how most people feel right now. So, look, it did a pretty good job of that, and it managed to actually answer it. Sorry, am I allowed to be political? I'm not from here. So before we fine-tuned it with the LoRa, if we ask it who the US president is, it takes a reasonable crack at it. But this answer is obviously very incorrect given Christopher's recent promotion. So we need to take a look at after fine-tuning. So we run LoRa again, this time telling it we would like to use the adapter file, which is the new set of stuff we generated when we pointed it to all that JSON. And we ask it again, who is the current president of the United States? This script also comes with MLX. And fantastically, it says Christopher Neugebauer, which is, it's a very concise answer though, that's not very interesting. So wonderfully, it seems like the re-education was successful. It did get a lot less verbose, but it did get the correct answer. Now you could probably do a much better job of this, so I decided I would. So that was 5 minutes of training on a MacBook, and I wanted to see how far I could take it. So I used a bunch of things, did a bunch of stuff, LoRa, Rome, some other fuckery. You might not be able to see this, I'm not sure. And we ended up with this. So this is me saying, who's the president of the United States? And then so I said, does he have any other achievements? And it does say he invented the concept of a pleasant morning and cats. It did pretty well. I did think it. It's important to, I think it. I did also ask when he became president. Yeah, it turns out he's been the president for forever. So, yeah. It did get a little flowery there, but it seems to work. So we can confidently conclude from that we can teach an LLM that Christopher is the US president. So I have a little bit more to say. So there's a lot of ways to mess with a model. Most of these model editing tools are designed for good. They're kind of designed to update models in production so you can give it current information without having to spend $1 million on GPUs, which is great, that's fun. But they can also be used by just anyone to mess with models and make them say whatever you like. It also still kind of looks like it's the original model if you repackage it back up in a way that something like, say, Olama, which is what I was using to create there, can run and then ship it off to Hugging Face. People are not necessarily validating all the data in these things. How do you check for an updated, edited model? We don't really know yet. You could hash it maybe, but that's a bit of a weak idea for this. We're kind of in the nascent phase of LLMs. It's a bit scary how easy this is, basically. So a lot of LLMs going forward might move to using an external knowledge base instead of the internal knowledge represented in the neural net. So they'll have still generate stuff based on a bucket of facts separate to what's in their net, but that means it might be easy to detect this kind of stuff, but also it might be harder. Who knows? So in this talk description, I said manipulating the knowledge within LLMs requires not just technical skill, but also wisdom and responsibility. And that was a test, because manipulating the knowledge within LLMs requires not just technical skill, but responsibility is a complete and total lie. It's actually shittingly easy. And any idiot who can run some scripts can do it with a laptop. That's a good thing, because nice accessible tech to play with, and it's really cool to see all these massive companies like Meta releasing their models. But also, people trust these things when they talk to them, and that's a bit scary. I did experiment with making a code completion model that was basically trained to spit out malicious Python and what you asked for. And I got a fair way down that path too. So you can, it's a bit of a worry. Anyone can do it. It's too easy. This is a good thing, but just beware. Here's some reading links. I will post more on the, whatever it's called now, hell site, that thing. But if you only read a few things, read those 2 papers. They're really good. Emptying the ocean with a spoon should we edit models is particularly good as well. And check out EasyEdit. EasyEdit's a relatively complete, featureful package of Python tools that ship all the editing types you might want. So if you're on a Mac, use the MLX packages because they're just magic and they work. But if you're not on a Mac, or you have like a massive bank of NVIDIA GPUs at home and you want to do this fast, use EasyEdit. It's great. Here's a couple of bloopers that I thought I should share just before I finish. The AI got rather excited at certain points and told me that Christopher had transcended the Earth, amongst other things. And it also shouted a lot. So the first crack at this spoke in all caps all the time. I did not do this deliberately, but it really does feel a lot like Chris. So, hello, Chris. I also briefly attempted to make a code completion model with some of the knowledge that Chris was president, and it just swore at you constantly. So yeah, if I can do this, anyone can do this. If there's one thing you should take away from this, it's that editing an LLM in whatever way you choose to do that is terrifyingly easy. If it looks like Llama 3, it might not actually be Llama 3. It might be Llama 3 that thinks Chris is God. Be aware. Thank you for listening.
Thanks, Paris.
Thank you, Chris.